Alright, right now what we're doing is we are trying to figure out what the rule is. What is going on? Well, now this one. There is, right now, let's look at this. So technically, I messed up here on the last one. I think. Yeah, I messed up on the last one. It's not really, it's a minor error. So I do apologize about that. The mix-up is just where the A should be, but right now I'm just trying to teach you the rules, so it's not too bad. Alright, so this here to here. Well, some people might think it's a rotation, alright, but we gotta look at it. Does this look like it would be in the same spot? Kinda does, but when you have these points, alright, this one's at 6-1 and this one's at 7-2. Alright, so these two spots technically are not in the same place. So these two are not rotations. Well, it can't be a reflection because it doesn't look like there's a line of reflection. The only thing it can be is probably translation. So this is how we figure out the translation. We're going from A to A prime. So we figure out how far is it going left or right, and how far is it going up or down. Okay. Well, it's going right. All right, so that means that we're always going to write like this, just like what we did before. Okay, we're going to have x. It's going to the right, so it's going to be x plus. Let's figure out how much we're plussing. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's going to be x plus 13. Now, since this is going down, it's going to be a y minus. Okay, let's see what the y minus is. We're going down 1, 2, 3, 4, 5, 6, 7, 8, 9. So the rule here is to get from here to here, we had to do x plus 13. That means move it right 13 and move it down 9. This next one, once again, it didn't shift positions, alright? It doesn't look like it's flipped upside down, anything like that. It didn't reflect. This, once again, has to be a translation. So we're trying to go from here up. Okay, so we're going from here to here. So we're going up. Alright, so we're going to have to go up and then left. Okay. Alright. So we're going to have to go up and left. Technically, I'm supposed to do it like this. My bad. Should go left first and then up, because the x comes before the y. Alright, so first, it's going left first, because we always got to do the x before the y. So it's going to be x, comma, y. So it's going to be x. Let's see how far it went over. Well, it goes over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's going to the left 11. Since it's going to the left, that means it's x minus. Since it's going left 11, it's x minus 11. Then we're going to be going up 1, 2, 3, 4, 5, 6. Since it's going up, it's going to be y plus. Since it's going up 6, it's going to be y plus 6. That's how you figure out the rules between these two. This next one, okay, this A is kind of in the wrong place. It should be down here. I was just trying to label it, showing you that this is the aftermath, but pretty much you can tell what it is. It's not a reflection because it doesn't reflect across anything. But what it is a it's not a translation because it's not in the same orientation, but it is a rotation, meaning it goes and turns. Essentially, it goes like this. It turns. It would be facing down right here, and since it's facing right this way, it's going to be a rotation. All right. Now, does it look like a rotation? All right. Then we got to count how many spaces it's going over. So it's going 1 quadrant, 2 quadrants. Now remember, when we go 2 quadrants over, that would be a 180-degree turn. Finally, this last one. All right, this looks like a mirror image of itself. So what we got to look for is the line of reflection. So this is 1, 2, 3, 4, 5, 6 apart from each other. If I draw a line up and down right here, this is 3 away from here, and this is 3 away from here, so obviously right here would be the line of reflection. Okay? So, reflection across x equals -1. Okay? Now the next part. Alright, asks you to find the dilation. Well, right here you see A and you see A prime. Alright, so essentially what you're trying to do is you're trying to figure out, did it get smaller or bigger? So A, the thing without the little tick mark, is the original, and A prime is the image. So it went from A to A prime, meaning it got bigger. This is what you should always do, is you should always take the prime, and you always divide it by the, not prime. Alright, so the thing with the tick mark divided by the thing without the tick mark. Well, the thing with the tick mark is a measurement of 20. Alright, so we have a measurement of 20 right there. The thing without a tick mark is a measurement of 5. So what we do is take 20 divided by 5, and you get a dilation of 4. Over here, A is the bigger one, and A prime is the smaller one. I mean, it's getting smaller, it's shrinking. And once again, we're doing prime over not prime, so prime is 4, not prime is 16. This can be reduced if we divide both the top and the bottom by 4. This gives me 1 over 4. Okay? Now, these word problems right here, they're kind of tricky. Alright? An object on a computer is 5 inches long. And when projected on the Promethean board, it's 17 inches long. What is the dilation? Well, think about this. Is this getting bigger or is it getting smaller? We originally have this thing on a computer. It's 5 inches long, and it's projected up on a board, which is 17 inches long. Okay? We can tell that this is going to probably be the A, and this is probably going to be the A prime type of thing. Okay? Because it's going from smaller to big. Okay, so what you'd have to do is you take the second number. So when you have these word problems, always take the second number and divide it by the first number. Okay, so 17 divided by 5 ends up being 5.4. Okay, so the dilation here is 3.4, my bad. It should be 3.4. 3.4. Second one, an object on the Promethean board is 12 inches long. When written on your paper, it is 6 inches long. What is dilation? So this one's going from big to small. Okay, so you always take the second number, which is 6, divided by the first number, which is 12. So when we reduce this, we can reduce it by 6. We get 1/2. So the dilation here would be 1/2. Or if you put 0.5, I'd accept that too.